Yeah, okay. Right, thank you very much for coming. So today we'll be talking about network LACP bonding or teaming with Mikrotik. So sorry for the delay. I had problem with my laptop here. Yeah, my name is Ahmad Mardiansyah and I'm from GLC Networks. Okay, so this is our agenda today. We'll do some review knowledge as a basic before we talk about the interface bonding, and then the bonding itself, and then some live practice, and then if you have question, and then please say something in the group chat. Okay, so introduction for those who are new: we are from GLC Garda Lintas Cakrawala. We are based in Bandung. Our areas are training and IT consulting. We do Mikrotik, Linux, and programming. We do regular events like our webinar, and then also other stuff like training, and then small workshop, okay, short workshop. My name is Achmad Mardiansyah. I'm based in Bandung as well. I'm a Linux user, a Mikrotik user, many users, okay. And then if you have LinkedIn, yeah, I have LinkedIn account, then we can connect to LinkedIn. Okay. Um, what else? Yeah, so this is our past project, past 5 years. Actually, I was working since 2003, 2004. Yeah. Yeah, officially 2004. Yeah, unofficially 2003. Yeah, in the last 5 years, we had project in Congo, in Malaysia, in Africa, and other countries, mostly related to networking, and then system administration, and then some programming stuff. Okay, so if you have what is it topics, please feel free to join us in our webinar here. Okay, so just tell us you want to share something as a presenter, and then we really like that. Okay, yeah, for those who are new to join, okay, please introduce yourself. At least we know where you are from. Okay, usually there are people from Indonesia, from Malaysia, from Philippines, from Europe sometimes, and from Africa. It's quite hard to see people from Australia and Taiwan or America, because I think because of the time zone. Yeah, people in Taiwan or Japan, it's very late over there, and then people in America, they are still sleeping. Yeah. Okay, so that's all. So if you don't mind, please say something about yourself. At least we know where you're from. Okay, so at least before we talk about the bonding, we assume you already know some stuff related to networking, Mikrotik router OS. Yeah, so that's all. And then please understand the concept of layer 2. Okay, so review prerequisite knowledge. So we know that in computer networking we have an encapsulation process. So we design the computer network communication based on layers. So layers actually is an abstraction of features. Okay, so every layer has its own feature. So it's like a programming. If you do socket programming, and then you can uh, you can basically design your own protocols. Yeah. So anybody have ever done any network programming before with a socket based on Java or C or C++, okay, or Python? We had a webinar about the network programming previously. Yeah, so you can take a look at it. Yeah, so basically it's data wrapped with another data, wrapped with another data, and then you keep doing it until it sends to the physical layer. Yeah, so and then every layer it has its own PDU, protocol data unit, and then in every layer we have its name. Okay, so we have in layer 4 we have a segment or datagram, layer 3 we have packets, layer 2 we have frames. Okay, and then sometimes we also refer OC model and then TCP/IP, so everyone knows this one. And then as you can see, I'm not getting details into the details about the headers, what the header looks like on every layers. Okay, so yeah, I will just skip those slides. But if you want to know, you can check our previous webinar. You can see it there. Okay, so basically, your data is wrapped with another data. So this is your data, and then you wrap with a TCP, and then add IP, and then add a layer 2. Yeah, so this is what you send, what you type on your WhatsApp, and this is actually what you send from here to here. Yeah, so that's how encapsulation looks like. Okay, so our header is much more longer than the data we type on the applications. Okay, so yeah, so that's the concept of protocols. Okay, protocol encapsulation, and then we are going down to the network devices, where we have end devices, intermediary devices, and then those devices are connected with the media, and then the media is based on the wireless or wired. Wired we have copper wire or a fiber optic wire. Okay, and then usually when we develop uh, network, we draw a physical topology. Okay, where we set up like this is layer 2 segment. Okay, the one on the red, and then this segment, layer 2 segment, will be joined with the router over here. So we have 3 routers, and then 1 2 3 4 layer 2 segment. Okay, and then we are sending to each other with uh, yeah, with the routing tables, and then before we set up the routing tables, we need to draw a topology, another topology that is focusing on internet layer, which is the layer 3. So here we are doing addressing, which is the segment, or sort no, not segment. Segment is layer 2. In layer 3, we usually call it subnet. Okay, so this subnet is this one. Okay, it's connected to this router, and then in every router they have routing tables where if you want to go this, and then if you want to go to this destination, go through this gateway. Okay, so as simple as that. And then in layer 2 we have very famous technology that is Ethernet. Okay, Ethernet is defined by IEEE 802.3, and then the media can be coaxial, fiber optic, or a twisted pair, copper wire. Okay, so the device that we require is a bridge or switch. Okay, and then everyone likes it because it's affordable, easy to install, easy maintenance, right? And then the way Ethernet work is CSMA CD. Okay, so if two hosts send at the same time, and then there will be a collision. Okay, so before they send, they have to sense, they have to check the medium, is there somebody sending or not. Okay, it's not, and then I will send. If two hosts sending at the same time, there will be a collision. So with the collision, everyone knows there is a collision, then we have to wait and then retransmit our transmission. Okay, hopefully when we transmit, nobody is sending. If another host is sending, and then there will be another collision, another collision, another collision, and then for that one, the operating system says that, oh, okay, medium is busy. Okay, so successful rate is very zero. Okay, so we have CSMA CD, we have CSMA CA. Okay, and then in Ethernet networking, we have protocol ARP. Yeah, address resolution protocol. With basically it's maps between layer 2 and layer 3. Okay, so yeah, this is ARP protocol, and then here's the header. Okay, so basically this is a frame, right? So we have a MAC address, and then here's the type, and then here's the um, frame for ARP, the field for ARP. Okay, so basically, so when PC number 1 wants to talk to PC number 3 and number 5, but now, PC number 1 do not know the MAC address, right? Why? Because it's new connected network. Okay, the host is just connected, so everyone do not know each other. So A will send a broadcast here, so it's a broadcast. So here's the broadcast address. Okay, and then this is the source address of the PC number one. Okay, and then here's the ARP header, and then here's the reply. Okay, so when they reply, okay, so this is what happened. Okay, and then here's the source address. Here's the destination address. Here's the source address. Okay, yeah, simple as that. So when you send a ARP request, it's a broadcast. When there is when somebody reply, it is a unicast. So it's from 1 to 1. Okay. So Ethernet is still evolving up to now. Okay, from 1 Mbps, 10 Mbps, 100 Mbps, 1 gigabit a bit per second. Yeah, 1 Gbps, 10 gig, 40 gig. What's next? 100 gig, 200, 300, 400. Yeah. So yeah, that's the technology of Ethernet. And then the higher is the more expensive. Okay, so here's the another evolution. So still keep evolving. You just Google it. Okay. Yeah, up to now, as you can see, it says here 100 gig. Yeah. I don't know when. Yeah. So here's the standards. Okay, and then you can see the speed that is reachable by the technology. Okay, so yeah, talking about the collision domain. So it's a domain where collision happens. We can split the domain by using um, from hub. We change it to a switch over here. Okay, and then we split the collision domain on every port. Okay, so it's very useful. Instead of using hub, we are using switch. And then we have a broadcast domain. Is the area where broadcast happens. Okay. Yeah, so here we can split the broadcast domain by using a router. Okay, or you can use port isolation and so on and so forth. Okay, another issue is loop. Okay, if you are using ordinary switch, unmanaged switch. Okay, and then especially when you send a broadcast, the broadcast will be replicated. Okay, it's not the one. Yeah, that's the difference. Okay, so when you send FFFF, so that FFFF frame will be replicated to this one and then this one as well. Okay, so switch knows that. I mean the switch knows that. Oh, okay. So this is FFFF, so I have to send to everybody. Okay, and then this one receive as well, and then they forward the frame to this one, and then it receive then forward to this one, and then another broadcast, another broadcast, another broadcast, and then after one is down here, and then everything goes back to normal. Oh, okay. That's because of the loop. Okay. Yeah. So yeah. So, yeah. For this one, we can use STP protocol to fight the loop in the network. Okay. So next is about the layer 2 technology, our main topic today, that is bonding. Okay. So we need to, when we talk about technology, we need to talk about the background. Okay, why this technology appear. Okay, so it's not like a random random events happening. Oh, okay, let's create bonding. Okay, and then pops bonding appear. No. uh, yeah, so for bonding, so imagine you have a topology like this. Okay, so this is your server, and then this is your switch, and then you have two Ethernet over here. Okay, so a long time ago, here is 100 Mbps. This one is 100 Mbps. Okay, And then during the, yeah, this is what happened when I was in 2007. Yeah, at that time I was a network administrator, and then at that time the speed was only 100 Mbps. Remember, 100 Mbps. Okay, and then during the daytime, the server is hosting the files. Okay, so lots of files is served in the network. Okay, you have tutorials, you have movies. Okay, you have MP3, lots of files over there. So people are very, very generous sharing their files, and then people just copy it from them. Sometimes they also spread virus, and then that makes that makes the network even worse. So yeah, problem is that file server is getting popular, very, very popular. In the beginning, when you copy, is very, very, very fast. Okay, but later on, when the server is popular, everyone knows that, and then, oh, during the peak hour, usually 11 o'clock, 10 o'clock until 15 o'clock. Okay, the server is very, very slow. Why? Because the traffic only reach 100. Cannot go higher. Why? Because it's the limit. It's the maximum data rate that is provided by the network interface card. Okay, so we cannot do that. So yeah, in our server, this is the problem. Okay, so we have an inbound traffic, and then we have an outbound traffic. So this is inbound, this is outbound. Okay, so this is our server. So because this is server, what we concern most is about the outgoing traffic. Okay, outbound traffic. So, and then this outbound traffic is already 100 Mbps. Inbound traffic is very, very small, maybe 10 Mbps, 20 Mbps. Very, 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 very low. Okay, why? Because people tend to download compared to upload, right? Yeah, so this is the people. Okay, so this is the people likes to download, okay, rather than upload. Upload traffic is just for sending a request, so like HTTP get something, and then you watch. As simple as that. So inbound traffic, it's just for requests. Yeah, lots of them are um, doing the outbound. I mean, just the download. Okay, and then from the server point of view, it is outbound traffic. So, any idea how can we double the capacity? Okay, so in the beginning we just only use one Ethernet card. Okay, so yeah, which capacity of the traffic that is full? Okay, inbound or outbound? Okay, so based on the server point of view, okay, so we are more concerned on the outbound. Okay, because that's what the server for. Okay, for serving people. Okay, and then in this case it's already full, 100 Mbps. It's all up. Okay, so we do analysis. We need to know how the layer 2 works. Okay, so we need to know outbound traffic, right? Okay, outbound traffic. So it is possible to send data from multiple interface, right? So for outbound traffic, and then sometimes we have a problem with the TCP sequence. Okay, because if we send data not in order, there will be a problem with the recipient, right? Because data, if you are downloading of several hundred megabyte movie, right? Movie, yeah, that's what we like most, right? Yeah, with our external drive, we like to collect the movie, yeah. Uh, yeah, so if you download and then most likely that protocol that we are using is TCP. So if we send the data not in a correct order, there will be a problem. Your files will be not in order, and then when the OS operating system saves the file, the files will be corrupt. Yeah, that's what happened. Okay. For outbound traffic, for inbound traffic, sorry. So this is your SRV. Okay, so this is inbound, this is your outbound. Okay, so for outbound traffic, okay, so what happened? So you have two interface card here, and then there will be a problem. Okay, if you set an IP address, where do you put the IP address? Interface number 1 or interface number 2? Okay, here. Okay, can MAC address? What about the MAC address? Remember the ARP. Okay. Yeah, this server is connected to a switch. Okay, and then the switch connected to host, right? And then they are in the same network, same segment. So same segment means they know the IP address, they know the MAC address because it's directly connected, right? Okay, so which MAC address? So because every network interface has its own MAC address, right? So which MAC address are we using? Okay, will that make other hosts confused? Okay, yeah. So that's the questions, that kind of questions that you need to think about. Yeah, when you do network bonding. Okay, so it's not like, oh, just technology you do here and there and then pop. Okay, done. And then after that you realize that, oh, okay, why it's not working. Okay, you don't understand how the layer 2 works, especially in networking Ethernet technology. Okay, so please understand, make sure you can you understand it well, and then you apply the bonding. Okay, so the proposed solution is LACP, defined by IEEE 802.3 AD. Okay, so it's a link aggregation, and then they updated to 802.1 AX. Okay, so yeah, so in order to provide this one, so we need layer 2 device that support standards. Okay, so what are the devices? The network interface card and then the switch. So the switch itself must support this LACP. Okay, and then the server also support the LACP here, both party. Okay, so because here you're using two Ethernet, right? Ethernet 1 and 2. Here you're using port 1 and port 2, right? So both parties um, should be able to support this protocol, okay, link aggregation protocol. So therefore it can increase outbound and inbound traffic both. Okay. Okay, guys, if you have questions, so please type in the group chat. Okay. So regarding to LACP, yeah, you know, marketing, Cisco, yeah, they call it Ether Channel, Port Aggregation Protocol, Juniper, Aggregated Ethernet, Avaya, BSD, Solaris Operating System, link aggregation, Linux, bonding, teaming. What about Mikrotik? Yeah, Mikrotik is based on Linux, so we call it bonding or teaming. Yeah, yeah, it's the same. Okay, next. So what is bonding? Yeah, so because uh, Mikrotik is based on Linux, so let's talk about bonding in Linux. Okay. So, what is bonding? It's a feature to combine multiple Ethernet-like interface. Okay, so as you can see, you can apply bonding on Ethernet. You cannot apply bonding on Wi-Fi. Why? Wi-Fi is not Ethernet, it's different things. Okay, can we apply bonding on whatever? What else? uh, uh, I don't know. Is there any alternative or ATM or frame relay or whatever? Yeah. Is there any other layer 2 technologies? Yes, there's a lot like GPON. Yeah. No, you cannot do that. Yeah. Bonding is for Ethernet like. Yeah. That one you can apply bonding. Otherwise, no. Okay. Okay, how it works. So here's the benefit. Okay, so we have Ethernet 1, Ethernet 2. So we combine into bond 0. Yeah. So it's not like a James Bond. So this is bonding, okay? Sometimes, not sometimes. Often we name our virtual interface bond 0. Okay, so here's the benefit. A high throughput and then failover. So if this one down, broken for whatever reasons, and then the network's yeah still accessible. Okay, with the failover. Okay, so how to do that? So we set up bonding interface and then set up monitoring. Done. As simple as that. Easy. Okay, so what about link monitoring? So bonding is broken when individual link fails. So we need to enable link monitoring. So yeah, so monitoring will monitor this one and this one. Okay. Yeah, if we don't have any monitoring, then how can we know the throughput? How do we know the failover, right? So that's the purpose for monitoring. Yeah, sometimes we can use ARP monitoring or MII monitoring. It depends on the driver. Okay. So in Mikrotik, we can say interface bonding link monitor is ARP. Okay, and then the ARP IP target is this one. Okay, so that's a CLI. And then let's talk about some mode. Okay. Yeah. Some method for bonding. Okay. So the first method is the official method, 802.3AD. Yeah. So for this one, if you have, let's say this is Mikrotik. Well, we can say Mikrotik like a router, like a server, right? So this is Mikrotik router. MTK, right? So you have two Mikrotik two ports here, Ether 1 and Ether 2, and then here's the switch, right? This is switch. So here you have a port number 1, port number 2. Okay, right. So two ports at both sides. Okay, so if we use 802.3 AD, so this switch must support that one, must support that protocol. So for outbound traffic, it provides load balancing. For inbound traffic, it can also provide load balancing. Remember, so most likely the outbound traffic is the one that is used most, okay, because it's easier, okay. So some frames send it through here, some frames send it to there. It's very easy to control bonding with the outbound traffic because yeah, that is easier. But for inbound traffic, no, it's not that easy. Okay. Yeah, because of the limitation. Again, please understand how the layer 2 works. Okay. So we have Ether 1 and Ether 2 over here. Okay. And then each interface has their own MAC address. And then when you do inbound, okay, and you will assign so which MAC address, right? This MAC address or that MAC address. Okay. MAC 2, MAC 1. So this is the one question that you might think about when you are learning how bonding works. Okay. Okay. What else? Another mode is balance round robin. RR means round robin. So this one we can use generic switch. So any switch is okay. Okay. I can provide failover. Yes. Outbound traffic. Yes. It's true. We can do so we can double the outbound traffic. Okay. So this is server. Okay. Port 1, port 2. Okay. So we can combine for outgoing traffic. So for example, this is 100, this is another 100, so outbound is 200. We can achieve that. Okay, but for inbound traffic, okay, uh, yeah, inbound traffic over here, as you can see, uh, it only use single interface, either this interface or this interface. So inbound traffic is only 100 Mbps. Okay, please be careful with that. So please do understand about the inbound traffic and then outbound traffic. Okay. Yeah, unless the load balancing is supported by switch. Okay, and then yeah, the switch can also increase the incoming traffic or inbound traffic. Okay. Next is XOR. Okay, same thing. Generic switch provide failover. Outbound traffic based on the hash policy. Okay, here. Yeah, source MAC and then XOR with destination MAC, XOR with packet type ID. Same thing for inbound traffic. So for outgoing, so for example, you have 100 over here, 100 interface card. Okay, so I'm talking about 100. Okay, so if it is outgoing, it's going to be 200 Mbps, but for incoming, only 100, unless it's supported by the switch. Okay, so this is to overcome out of order packet arrival. Again, this is a good technology, but if you don't use it wisely, you might have a problem. Okay, and then broadcast. Okay, so for yeah, this is we can provide failover. Yeah, for outbound traffic is no aggregation. Yeah, send same data over multiple interface. Okay, outbound, inbound traffic, no aggregation. Yeah. So yeah, yeah, that's the broadcast, and then active backup. Yeah, same thing. Uh, Failover. So one is you have two connections. Only one is active. Okay, the other one is just for backup. Okay, so there is no increase in terms of data rate. And balance TLB. Yeah, transmit load balancing. So it's yeah, again for outbound traffic. Yeah, it can do aggregation, but for inbound, no, it's not. Yeah, so this is balance TLB. So you have a Mikrotik router over here. Okay. So for incoming, it's 100. TLB means transmit load balancing. Okay. So when we do transmit means outgoing, right? So we have a 10 Mbps, 5 Mbps. Yeah. So yeah, total is 15. Yeah, 15 goes to here, 5 goes to over here, 5, and then here is another 5. Okay. So as you can see, for incoming, yeah, for incoming, let's say this is 10 Mbps, okay, 10 Mbps interface. Yeah, this is 10 Mbps interface, not 100, it's 10. Okay, so for incoming, so this is incoming. Incoming only receive on one interface only. Okay, so as I said, yeah, for incoming, it's only one interface. But for outgoing, we can use multiple interface. So usually that's what happen in bonding. Usually we do bonding for increasing the outgoing interface. So as you can see, we in our bonding, in our incoming or inbound traffic, we should have 5 plus 5 plus 5, right? So total is 15, has to be 15 over here. Why is it only 10? Because the capacity is only 10. Yeah, okay. So unless the switch support, and then we can uh, we can split the traffic, split the 15 Mbps into 10 Mbps and then another 15. Okay, but be careful, okay, be careful. Please do not change the order of the packets. Otherwise, the file will be corrupt. Okay, so here's another balancing. Okay, yeah, ALB for outbound load balancing. So most of the algorithm are maximizing the outbound. Okay, so usually it's applied on the server side. Yeah, where you need to provide lots of you need to serve lots of requests coming from your clients. Okay, yeah, this is balance ALB. Yeah, so as you can see, for incoming, yeah, let's talk about incoming. Maybe I will use yellow color. Yeah, for incoming, so we have 15 Mbps, and then we kind of um, splitting the incoming traffic into this interface and this interface. As you can see, for incoming, it's 10 and 5. Okay. For outgoing, it's the same. Okay. Yeah. Okay. So let's do a simple exercise with the Mikrotik. So I will use my own Mikrotik over here. Let's see. Okay, so before we close, oh, okay, I need to update the slides. Yeah, so yeah, thank you for your attention. So these are some questions that many people is asking. Yeah, yeah, for feedback, you can see it here. Yeah, we have a Facebook page for you. If you want to get some information, we have website. Slide will be available on Slideshare. A recording will be available on YouTube. Okay, so let me access my Mikrotik over here. Oh, I haven't shared the Mikrotik, sorry. Okay. Yeah, okay, so hopefully you can see this. Yeah, let me check. Oh, the annotation is still on. Okay, let's see which interface is available. 5 and 2 is empty. Okay, so we can remove either 5 and 2. Yeah, I don't have this switch, yeah, unfortunately. Yeah, but we can try. This is just a lab to create a bonding. Okay, so bonding is quite easy. You can just add here like bonding 1. Okay, and then the slave interface. So this is the master interface. Okay, where the master interface has its own MAC address here will be changed. Okay, because again you need to understand how how layer 2 works. Okay, So every time you create an interface, either virtual interface or master interface, the MAC address will be assigned on the master interface. So the MAC address on the slave interface will be not available. Okay, so we will set up a slave on ether 2 and ether 5 over here. Okay, so we are a load balancing between ether 2 and ether 5, and here are the modes. Okay, the modes that we are talking about. And then link monitoring is either ARP or MII. Transmit hash policy at layer 2, 3, or 4. And then here's the status. And then that's it. As simple as that. Okay, so as you can see, MAC address on that bonding interface is this one. So as you can see, yeah, I'm gonna display MAC address over here. Oh yeah. Okay, as you can see, this is how it looks like. Okay, so as you can see, so ether 2 has this MAC address. Okay, ether 5 is using this MAC address over here. Okay, this is ether 2, this is ether 5. Okay, yeah. So those interface are slave interface. Okay, so the MAC address that is assigned on those interface will be gone. Okay, so now we check the master interface, which is the bonding one, and then here's the MAC address. So E4 8D 8C 52 FE 1D. So it took interface from ether 2. Is it always like that? Not always. But we can define our own MAC address over here, like 44, for example. Let's say, yeah, it's MAC address 112233. Yeah, why not? So this will be our MAC address. Okay, so again, yeah, this bonding interface is very useful for outgoing interface. So we can always guarantee that this this bonding will have a higher outbound throughput. Okay, outbound data rate. But for incoming, it depends on the switch that we are connected to. Okay, understand? Right, guys. So I think that's all for today. Is it too fast? No. Any questions? Are you confused or not? Oh yeah, actually we have info regarding internship. So guys, I would like to ask your help regarding our internship. So let me post on the group chat. Yeah, so we open internship opportunity. Click jobs. I think it's over here. Yeah, here it is. Okay, so yeah, so please share this information to your friends. Okay, so hopefully some of them are interested. Yeah, so this internship is 6 months. Okay, please share, please. Okay. The deadline is 21st December. Yeah, but we can extend it. Okay. Yeah, this is for Indonesian only. Okay, so I will update the the, the form over here. Okay, any questions? Hello, guys. No questions. Oh, it's very silent today. Anyone here from Indonesia? Hopefully, yeah. Or not. Okay, so if no questions, and then I think it's a time for photo session. Okay, please turn on your cameras. Hello. So, as a conclusion, yeah, bonding is one way to increase data transfer. Yes, that's true. But you need to understand how layer 2 works, okay? Especially the ARP, address resolution protocols, the MAC address, okay? And then the understanding about um, inbound and outbound traffic, how it looks like, okay? Well, so I think that's all, guys. So let's do photo session, okay? Oh, 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 oh. Okay, so okay, so I will count 1 to 5, 1 to 3, 1 to 3, and then the thumbs up. Okay, almost forgot. 1, 2, and 3. Yeah, okay. Okay, guys, I think that's all. Thank you very much for coming, and then see you in the next webinar. Thank you and have a nice day.